Good evening, guys. Today we will understand the topic of theory of computation, a transition function, and properties of transition function. So, first of all, we will understand what is transition function. A transition function is defined on every state for every input symbol. A transition function is defined as delta, where delta is equal to q into summation, which gives a set of q, where Q is a set of all states and summation is a set of all inputs like A, B, C, D, 0, 1, etc. Now we will understand the properties of transition function. So there are many properties of transition function. We will read and understand one by one. So first property of transition function is domain and range. Domain. The transition function is a function that maps each state in the set Q and each input symbol in a set summation to a state in the set of Q. In other words, the domain of the transition function is Q into summation. Now range. The range of the transition function is Q. Now we'll understand the second property of transition function, which is determinism. The transition function must be deterministic. This means that for each state in an input symbol, the transition function must specify a unique next state. In other words, there cannot be two different next states for the same state and input symbol. Now the third property of transition function is totality. The transition function must be total. This means that for every state and input symbol, the transition function must specify a next state. In other words, there cannot be any state and input symbol pair that are not defined as a transition function. Now, fourth property of transition function is consistency and with accepting states. The transition function must be consistent with the set of accepting states. This means that if a DFA is in a accepting state and it read an input symbol, then it must be transition in another accepting state. In other words, it is not possible for the DFA to transition from an accepting states to a non-accepting states. Now the fifth property of transition function is unique next state. So the transition function must always lead to a unique next state for any given state and input symbol combination. This ensures that the behavior of the DFA is predictable and consistent. Now there are two more properties of transition function. Delta, where input is Q and that power is equal to Q. It means that the state of a system can be changed by the input symbol. Now second property is for all strings W and input symbol A. It means the transition where Q and AW is input and the transition of whole transition and W is output. For other, where the transition of a Q and WA is equal to transition of whole transition of QW and A. It means that the states after automata consumes or reads the first symbol of a string AW and the state after automata consumes a prefix of a string WA. Now we will take an example to understand the properties of transition function. So here an example where we will make a DFA for accepting strings ending with 1. So here we require two states Q0 which is starting state and Q1 which is ending state. Now here we require alphabets like 0 and 1 for the inputs. So the transitions of the states and alphabets are the transition of where Q0 is input and Q0 is a state and 0 input, we will move to Q0 state. And when Q0 is the input, Q0 is a state and we will give input 1, then where will we will move to next state, that is Q1 state. And when the transition when q1 is a state and we will give input 0, then we will move to q0 state. For other q1 state, when we give input 1, we move to q1 state that itself. Now here is a state diagram of DFA. Here q0 is a first state and q1 is a final state. So q0 is starting state. Here from initial when we give input 0, it will remain on a q0, and when input is 1, it will move to q1 state. And when there will be 1 on a q1, then there will be it will remain on q1 state. And when input is on q1 state is 0, then it will move to q0 state. Like example, a string is having 0 1, so 1 is ending with a 0 1, so 0 will remain here and 1 will move to q1, so this string accepted. Let's take another example, 0 1 1. So 0 here accepting, so it will remain on the q1 state, q0 state. Then for 1 it will move to q1, and for q1 there is the input 1, so it will remain on q1, so it is on final state. Here this is a transition table of DFA. So thank you guys.